Hello. Today we are going to be solving quadratic equations by factoring. So we will be using the zero product property, which states if you multiply two numbers to get zero, either the first number has to be zero or the second number has to be zero. So one or the other. So the way this applies to factoring is if you have two different things being multiplied together, either x minus 9 in this case has to be 0, or 5x plus 2 has to be 0 in order to make this equation true. So what we can do is we can take and set these each equal to 0, and then we can solve each of those for x. So we would get, for this one, we would end up getting x equals 9 and x equals negative 2 over 5. So looking at the next one, we have three different things being multiplied. So what we're going to do is we are going to set each of those parts equal to 0, and then you're going to solve each of the resulting equations in order to get your answers for x. So for this one, we get x equals 0, x equals 1/2, and x equals negative 3. So let's go ahead and try numbers 3 and 4 here. So now what we have is we have, again, three different things multiplied to equal 0. So we're going to go ahead and start by setting each part equal to 0. Now with this first one, 3 equals 0, this one doesn't have an x with it. And so we ended up with this false statement. 3 does not equal 0. So if there's no x, there's no solution that goes with that factor. So we can just say, well, that factor is not true, so then move on to the other ones and only solve those ones. So we would get, for this one, two different solutions. One of them is negative 3/2, and one of them is positive 1/3. So let's try one more. We have, again, three different factors being multiplied and set equal to 0. So we're going to set each of those parts equal to 0. 2 does not equal 0, so we do not get an answer from that one. And we take and we solve the other two equations for m, and we get m equals negative 10 and m equals positive 3. So this helps us to solve equations by using a skill called factoring. So if we are able to factor things, we basically are undistributing things or unmultiplying them to get all of those parts and make it look like our first examples here. So in order to do this, we have step-by-step instructions. First thing, you got to get it equal to 0. Then you factor, and then you set each factor equal to 0 to solve. So for this first one, we have a 64 on the wrong side. So we're going to move it over. We get x squared minus 12x minus 64 equals 0. So we did step 1. Step 2 is to factor now. So for this one, we are looking for what multiplies to get negative 64, but adds to get negative 12. This one, 8 and 8 doesn't work. You're going to have to kind of think about a couple solutions here. It's going to end up being 16 and 4, but it only works if the 16 is negative. Because your a value is 1, we're allowed to write our factors right away, and it would be x minus 16 and x plus 4. So step 2 of factoring is now done. Now this looks like our problems did earlier, so what we're going to do is we're going to set each factor equal to 0 and solve the resulting equation. So for this one, we would add 16 to both sides, and the other one we would subtract 4. So our solutions for this one are x equals 16 and x equals negative 4. So for our next one, step 1, get the equation equal to 0. Well, that one's done already for us. Step 2 is to factor. So these ones here, you have a missing b term, and the first term and the last term are perfect squares, and they are separated by a minus sign, which means we can do the difference of two squares. So as we're looking at this first term is 3x being squared. This last term is 4 being squared. So once we identify those, what we can do is we can say my first term in each parentheses is 3x. My last term is 4. One of these factors has a positive sign and one of these factors has a negative sign in order for this to actually work. So that would be step 2 of factoring. Step 3 then is to set each of these parts equal to 0 and then solve the resulting equation. And so for this one, we do end up with 2 answers. It is negative 4/3 and positive 4/3. So this is how we solve equations from factoring. On the back side, we have just a bunch of different examples here because factoring looks different for each problem. So let's go ahead and try a couple of these together. If you want to pause the video and test yourself and see how many of these you can do without an explanation, that would be fantastic. If you are needing more of an explanation, feel free to stay on the line here and kind of hear how this works. So for the first one, we're going to get this equal to 0, and it already is. Then we're going to factor it, and it's another case where a equals 1. So when we do our number pairs of what multiplies to get 64, but adds to get 16, when we think through those number pairs and try a couple out, we end up on 8 and 8. So because a is 1, this was our shortcut. We could just jump to our factors. We get x equals 8 and x equals 8. So it is now factored. We set each of these equal to 0, and we solve each of the equations. Now both of these end up getting negative 8 as your answer, so you could write it twice, or you could just write it once. Either one is fine. Number 8 is also equal to 0 already, but here's our first time we have this 2 out in front. So to factor this one, we're going to have to use split middle term. So we are going to multiply a times c. So for this one, we are looking for what multiplies to get negative 12. Again, we're doing 2 times negative 6. And now we're looking for what adds to get our middle term, which is 1. So 1 and 12, 2 and 6, 3 and 4, that's going to be the one that we settle on as long as 3 is negative. Now we cannot write x minus 3 and x plus 4. Instead, in order to factor it, we are going to have to rewrite this problem. So 2x squared stays the same and minus 6 stays the same, but we're going to split up the middle term to our new factors, which were negative 3x and a positive 4x. Then what we do is we chop it down the middle and we look for what the first 2 terms have in common, which is an x. And when we factor out an x out of each of those, we are left with a 2x and a minus 3. We also look for what the next 2 have in common, and that would be a 2. And if we divide each of those by 2, or if we factor out that 2, we get a 2x minus 3. In order for split middle term to work, these 2 factors have to be the same, and they are. So we're going to go ahead and write 2x minus 3 as one of our factors. And then our coefficients here represent our other factor. So it would be x plus 2. So now this is factored. In order to solve, we're going to set each of these equal to 0 and solve those equations. So for this one, where you get x equals 3/2 and x equals negative 2. Okay, for number 9, now we have it equal to 40. So we are going to have to move the 40 to the other side. So we get 2x squared plus 18x plus 40 equals 0. So step 1 done. Step 2 is to factor this, but I'm looking at these numbers and I'm noticing that they are all multiples of 2. So I'm going to go ahead and take out a GCF of 2 from each of them. Then what I noticed left behind, I can just do my number pairs with. So I'm looking for what multiplies to get 20, but yet adds to get 9. So once I get my numbers of 5 and 4, I can write my answers as factors. So I'm going to keep my GCF out in front, and then I'm going to write x plus 5 and x plus 4. And then again, I can do this because a equals 1 for this one. Now this is factored. I'm going to set each factor equal to 0. And then I'm going to solve them. My first one, 2 does not equal 0, so that's the one where you cross off 2 and you say that that is not a solution. My other ones, I do end up with nicer answers. I get x equals -5 and x equals -4. For number 10 here, it's already equal to 0, so now I'm going to go ahead and factor this. So my first rule of factoring is look for a GCF, and I notice my GCF is x squared. So I'm going to divide out my x squared from each of these, and I would be left with x minus 5 as my other factor. Then I'm going to set each factor equal to 0 and solve. So one of my solutions is 5. The other one, in order to solve it, I would take the square root of 0, and it would remain 0. So I do get 2 answers for them, and that one is 0 and 5. So now we have this one here. It already equals 0. The first rule of factoring, once again, is to look for our GCF, and we do have a GCF for this one of 2. If we take out a 2, we are left with 2x squared plus 7x plus 6 equals 0. Here's another example where we have to do split middle term. So we are looking for this one for what multiplies to get 12, but adds to get 7. Those numbers would be 3 and 4. So we're going to leave the GCF out in front. We're going to bring down the 2x squared and the 6, but we are going to split up this middle term to 4x and 3x, and you can write that in either order. You're going to chop this in half, and the first 2 terms have a 2x in common. You'd be left behind with x plus 2. The next 2 terms here have a 3 in common, and you would be left behind with x plus 2. Since the x plus 2's match, that is your first factor, and 2x plus 3 would be your other factor, and we want to make sure we bring down our GCF that we took out earlier. Now we're going to set each factor equal to 0, and we're going to solve those equations. 2 does not equal 0. For this next one, we get x equals -2. And for this last one, we should get x equals -3/2. You can show your work for that one if you want to see where that comes from. For number 12 here, we're going to move the 9 to the other side. We get x cubed plus x squared minus 9x minus 9 equals 0. We're going to chop this in half. The first 2 terms have an x squared in common, so we're going to divide out x squared. And when we do that, we get x plus 1. Be careful that you still have that x plus 1. The next 2 terms have a -9 in common. Make sure you are dividing out the negative sign. Then I get x squared minus 9 and x plus 1. But x squared minus 9 can factor one more time. That is the difference of 2 squares. So I end up with 3 different factors that I need to set equal to 0, x minus 3, x plus 3, and x plus 1. And when I solve each of those, I should get a +3, a -3, and a -1 for my answers. So thank you very much for listening. I hope this helped.